Hello students, welcome back to the classroom point. In our today's class, we shall discuss some relations between the certain concentration terms. These relations are very small, but will give the great impact in solving the questions and they save the lot of the time. In our previous class also, we have seen the relation between the molarity and molality. Now let us relate this molarity and molality with the mole fraction of the solute. Let's begin the class. Relation between molality and mole fraction of solute. So let us see the relation first. We know that mole fraction of solute, let us take x2 as number of moles of solute divided by number of moles of solvent plus number of moles of solute. And mole fraction of solvent I am taking it as x1, that is equals to number of moles of solvent divided by number of moles of solvent plus number of moles of the solute. Now let us take the ratio of these two. Mole fraction of solute divided by mole fraction of solvent is equals to N1 plus N2, N1 plus N2, they get cancelled out, so that it gives the number of moles of solute by number of moles of the solvent. This is also one of the relation which helps us in solving the questions. And from this we are going to relate the mole fraction of the solute with the molality of the solution. Now from this relation, let us take mole fraction of solute by mole fraction of solvent equals to number of moles of solute divided by number of moles of the solvent, means mass of the solvent by molecular mass, means weight by molecular weight of the solvent. So I am taking the weight of the solvent as 1 into molecular mass of the solvent goes to the numerator, so it becomes the molecular weight of the solvent. Now multiply the equation both sides with 1000. So now by multiplying the equation on both sides with 1000, so it will not make much difference because 1000 get cancelled out, so that here we can write down the mole fraction of the solute by mole fraction of the solvent into 1000 is equals to number of moles of solute divided by weight of the solvent. Weight of the solvent always to be taken here in the grams only, into molecular weight of the solvent, this is also in the grams, into 1000. So we know that molality equals to number of moles of solute into 1000 by weight of the solvent in grams. So in this place we can use the molality. So that term is present here. This is the way. Number of moles of solute into 1000 by mass of the solvent is there. So in that place we can use the molality, so that here we can write down that 1000 x2 divided by x1 is equals to molality into molecular weight of the solvent. We want the molality here, so molality equals to 1000 x2 by x1 into molecular weight of the solvent. So let us try to see one question how to use this formula. Example, find the molality of an aqueous solution whose mole fraction is 0.2. So mole fraction of the solute is given as 0.2. Now let us try to solve this one. So molality equals to 1000 into 0.2 divided by, we know that mole fraction of the solute plus mole fraction of the solvent x1 plus x2 is equals to 1, then x1 is equals to 1 minus x2, x1 is equals to 1 minus 0.2 equals to 0.8. That value is substituted here. So that is 0.8 into molecular mass of the solvent. Here they said aqueous solution. So that molecular mass of the solvent is 18. So let us try to solve this part. 0.2 into 1000 equals to divided by 0.8 equals to divided by 18. The value is 13.88. Is the molality. So like this we can use this question and formula. Now let us see the relation between the molarity and mole fraction. Relation between molarity and mole fraction of solute. Similar, from this term onwards we shall begin the same relation which I will take here. x2 by x1 is equals to number of moles of solute by number of moles of the solvent. Now multiply both sides with the 1000 by volume of the solution. So multiply the above equation with 1000 divided by volume of solution in ml. So that we are going to get that x2 by x1 into 1000 by volume of solution in ml is equals to n2 by n1 into 1000 by volume of solution in ml. We know that molarity is equals to number of moles of solute into 1000 by volume of solution in milliliters. So this particular term, instead of this term I can use the term molarity. So that here we can write down that 1000 x2 divided by x1 into volume of solution in milliliters is equals to molarity divided by number of moles of the solvent. So that molarity is equals to 1000 x2 divided by x1 n1, where n1 stands for the number of moles of the solvent into volume of the solution in milliliters. So using this relation we can relate the molarity with the mole fraction. There is one more relation. The relation between these terms is molarity equals to, we can write down that dx2 by x1 m1 plus x2 m2. If density, mass, everything we introduce, we get this relation. D stands for the density of the solution, x2 means mole fraction of the solute, mole fraction of the solvent x1, molecular mass of the solvent, molecular mass of the solute, again mole fraction of the solute. So by substituting these values also we can get the, we can relate the molarity with the mole fraction of the solute. Now let us see how to relate strength, what is the strength and how to relate this strength with the different concentration terms. Let us see what is the meaning of strength. Grams per liter. Strength is also a type of a mode of concentration term, but instead of this strength we go always with the different concentration terms, molarity, molality, normality, mole fractions, which gives the a clear picture about the concept. Anyhow, strength gives only the mass of the solute present in the given liter of the solution or given volume of the solution. Let us see what is the strength meaning exactly. It is the mass of solute dissolved in 1 liter of solution. That's why here units you can see that grams per liter is there. So that strength of any solution is equals to mass of solute, that in grams, divided by volume of solution in liters. We know that 1 liter is equals to 1000 ml. So if the volume of the solution, if you would like to take in the milliliters, it has to be multiplied with the 1000, so that the strength, then this is one formula in liters. Then the strength is equals to mass of solute in grams divided by volume of solution in milliliters into 1000. Then how to relate this strength with the molarity and the normality? So let us see that molarity is equals to weight of solute divided by molecular weight of solute into 1000 by volume of solution in milliliters. So here mass of the solute, here also mass of the solute is there, 1000 term, volume of the solution milliliters. So in this place we can write the strength and send the molecular mass this side, so that we get the strength is equals to molarity into molecular weight of the solute. Similarly, we can relate the strength with the normality also. So let us take the normality, that is weight by equivalent weight of solute into 1000 by volume of solution in milliliters. Again, similar in the case of the molarity, here also weight into 1000 by volume of the solution can be replaced by using the strength and send the equivalent mass that side, so that we get the strength of the solution is equals to normality into equivalent weight. So from these two relations, where strength equals to molarity and molecular weight of the solute, and strength is equals to normality into equivalent weight of the solute. So from these two equations, we can get the one more important equation, that is the relation between the molarity and the normality also. So let us see here from equation 1 and 2, we get, see, since left hand side terms strength is same, so that we can equate the right hand side terms, then we can write down that molarity into molecular weight of the solute is equals to normality into equivalent weight of the solute. Then if you want the normality equals to molarity into molecular weight by equivalent weight of the solute, and this value gives the n factor, so that normality equals to molarity into n factor. N factor calculations we already did in the previous classes. Please do watch that classes. Now let us solve some questions how to use these formulas. So example, find the strength of a solution. So let us take the two different solutions where 6 grams of solute is in 250 ml of solution. Second one is 2 molar of HCl solution. So these two terms we have to calculate now. So solution for this is, first formula here milliliters, here also volume is given in the milliliters only, so that strength is equals to mass of solute given is 6 grams, volume of solution given here is 250 ml into 1000, so it goes 4 times 24 grams per liter. Similarly, let us try to calculate the strength of 2m HCl solution. So we know that molarity and strength are related by this formula. So that strength is equals to molarity 2 into molecular mass of the HCl is 36.5 grams per mole. So this is equals to 73 grams per liter. Like that we can relate this strength with molarity and strength calculation. Now let us see here how to relate the means what calculations we can solve using the molarity and the normality. Example, find the normality of 2m HCl solution, 1.5 m H2SO4 solution. Let us take 2 m aluminum hydroxide solution, and the fourth one is 4 m H3PO4 solution. Imagine, since their reactions are not given, we have to consider their complete ionization process, that is n factor value, acidity for bases and basicity for the acids. We have to consider that the reaction is completely taken place. That means complete neutralization has been taken place. All replaceable H plus ions and OH minus ions involved in that particular reaction. So that's why here, let us take first one. Normality equals to molarity given is 2 into its n factor. HCl can give only one H plus ion. So 2 into 1 is equals to 2 normality. Next, second one, normality of the 1.5 H2SO4 solution. Here 1.5 molarity is given, so that 1.5 into H2SO4 can release 2 H plus ions in its complete neutralization process. So that we can put that 2 value here, its n factor value. So its value is equals to 3. So it is a 3n solution. Next, normality is equals to 2m aluminum hydroxide. Aluminum hydroxide can replace the or can produce 3 OH minus ions. So its acidity is equals to 3. That means n factor value is equals to 3. Then here 2 into 3 is equals to 6n aluminum hydroxide solution. Let's see the next one. Normality of H3PO4. Here molarity is given 4 and its normality, since H3PO4 complete basicity is equals to 3, so we can write down the 3, so that we can write down here it is a 12n. So like this we can relate the normality with the molarity, and molarity also normality. If you want the only molarity, then you have to divide the normality with the n factor. If the reaction is given, then based on the reactions, n factor value has to be calculated, that we discussed in our previous classes. Let's calculate another concentration term, that is calculation of the ionic strength also. Ionic strength, usually represented by the letter mu. So this term is used when two or more ionic solutions are mixed. So this is used to calculate the total ionic strength. So usually ionic compounds, when mixed together, their concentration may change, or else if you want to calculate the total concentration of the ions in grams per liter, then here we have to go with this ionic strength calculations. So ionic strength calculation, total ionic strength is equals to half of sigma Cz square, where C equals to concentration of ionic solution in terms of molarity, Z equals to charge on each ion. Let us take one calculation to make sure this formula. So here let us see calculate the ionic strength of 0.1 m solutions of copper sulfate and aluminum sulfate. So both equal volumes of both solutions are mixed, and where their concentration is 0.1, copper sulfate and aluminum sulfate. So here ionic strength is equals to half of copper. Every solution concentration is 0.1 only, so that here C stands for the concentration 0.1 into copper sulfate. We know that it dissociates into Cu2 plus SO4 2 minus ions. So here copper concentration is 0.2 and its charge is 2 square. So this is about the Cu2 plus sulfate ion. Sulfate ion is also only one sulfate ion is there, so 0.1. Again its charge is equals to 2, so that 2 square. This is for the sulfate ion. Plus, now let's come to the aluminum sulfate. We know that aluminum sulfate dissociates into Al2SO4 taken thrice, dissociates into 2 Al3 plus ion and 3 SO4 2 minus ions. So there are 2 Al plus ions with 3 plus charge. There are 3 sulfate ions with 2 minus charge. So that here 2 into aluminum ion concentration is 0.1 into its charge 3 square plus 3 sulfate ions. So 3 into again concentration 0.1 into its charge 2 square. So this is about the Al3 plus ion, and this is about the sulfate ion. Now let us try to solve this one. So here this is 4 into 0.1, 0.4, here also 0.4, and here it is equals to 9, 0.9, 2 into 0.9, 1.8, plus here it is 4, 0.4, 0.4 into 3, it is 1.2. So 1.2 and 1.8 value is equals to 3, 3 plus 0.8, 3.8. So that mu equals to half of 3.8, it goes it is equals to 1.9. Let's solve one more question. Example number 2. Find the total ionic strength of a solution obtained by mixing 100 ml of decimolar aluminum sulfate and 100 ml of 0.2 m Na2SO4 solution. So two equal volumes are given. So let us make the double the volume. Why? Because here total volume of the solution in the previous example I used the equal volume. That is a small correction. Why? Because equal volume we should not take that one directly molarity is given. If equal volumes are given means it has to be diluted. That we are doing now. So total volume of the solution is equals to 100 ml plus 100 ml. That value equals to 200 ml. Now let us calculate. Decimolar means 0.1 m. So find out the molarity of aluminum sulfate. Al2SO4 taken thrice in the total volume. Its one molarity is 0.1, that is of 100 ml, but after mixing the total volume of the solution becomes the 200 ml. So in that 200 ml we have to calculate its molarity. So then its value equals to molarity into volume divided by total volume. Molarity of the aluminum sulfate is 0.1 and volume is equals to 100 ml. Divided by total volume is equals to 200 ml. So this value is equals to 0.05 molarity of aluminum sulfate is present. And molarity of sodium sulfate, Na2SO4. Here also molarity into volume divided by total volume of the solution. So molarity is given as 0.2. Again volume is equals to 100 ml. Divided by total volume of this solution is also equals to 200 ml. It goes 2 times, it goes 0.1. So the value equals to 0.1 m. Now this final concentrations we have to use in the calculation of the total ionic strength. So total ionic strength, half of, let us see here, Na2SO4 dissociates into 2 Na plus and SO4 2 minus ions. Al2SO4 taken thrice dissociates into 2 Al3 plus and 3 SO4 2 minus ions. So how many number of ions are these? Number of ions we have to consider it. So let us take here. Let us consider the sodium sulfate. Sodium sulfate concentration is 0.1. 2 sodium ions are there. So the 2 into 0.1 into charge on each sodium is only 1, so that 1 square. This is about the Na plus ion plus sulfate ion. Only one sulfate is there, its concentration is 0.1. So 1 into 0.1 into charge on sulfate ion is 2, so that it will be equals to 2 square. This is about the sulfate ion from sodium sulfate. Next, aluminum ion, 2 aluminum ions are there, so that 2 into each aluminum ion concentration is 0.05. 0.05 into charge on every aluminum is 3, so that we can write down that 3 square. This is about the Al3 plus ion. Next sulfate ion, 3 sulfate ions are there, 3 into each sulfate ion concentration 0.05 into charge on sulfate ion is 2 square. So this is about the sulfate ion. Now let us try to simplify this one. Mu equals to 0.1 into 2, that value equals to 0.2 plus 2 square means 4. 4 into 0.1, 0.4 plus this is 3 square means 9. This value equals to 0.1. 2 into 0.05 means 0.1. 0.1 into 9 equals to 0.9 plus this equals to 4. 4 into here 3 into 0.05. This is equal to 0.15. 0.15 into 4 is equals to 0.approximately 6. So here 0.6, 0.4, that value equals to 1. 0.2, 0.9, 1.1. So 1 plus 1.1, that is 2.1. So mu equals to half of 2.1. It goes approximately 0.5. So the value equals to 1.05 grams per liter is the ionic strength. Strength is always for the grams per liter. So like this, we can calculate the ionic strength of the ionic compounds which are obtained by mixing the 2 or more solutions. I hope you understand this class. If you have any doubt, please do send your doubts to the classroom@gmail.com, and don't forget to subscribe the channel. Thank you one and all.